All right, we're on.
Happy New Year.
Okay. So, we've learned a few different techniques to find the value of logs or to solve exponential equations. But what happens if we get a log like this one down here, log base 3 of 7? We can't use any of the log laws that we learnt yesterday to try and divide by things or multiply things. That's not going to work. It's not a base that we can put into the calculator. We need a different technique. And the other problem, these questions down here. 3 to the power of x equals 5. Okay, normally when we have those kind of equations, we want to make the bases the same so that we can solve them. But it's not possible to make a 5 a base of 3. So this is the last log law that you need to know about. You can change the base of your logarithm to be anything that you want with this formula. If you have log base a of x, if that's your starting logarithm, you can change the base to be whatever you want. So in the formula they used b. I'm going to make it log base b of whatever the number was on the end of the logarithm goes up there. Log base b of x over log base b of whatever the original base was. So the original base goes here and the large number, the top big number goes there. Okay, now if you're going to choose a base, you're either going to choose base 10 or base e because they're the ones that you can put in your calculator. So let's do this for question number 1. I want to find out what log base 3 of 7 is. So I'm going to choose a base of 10. I'm going to change that to be log base 10 of 7 over log base 10 of 3. Do you see how that formula works? And then you just get your calculator out, and you'll need to do it. I don't have an online one. This is a different computer. So you'll have to log, remember, is the LOG one. You won't see the 10, but it knows it's a base 10. So you go log 7 over log of 3. And it says 4 significant figures. So what did you get?
1771.
Perfect. And there's 4 significant figures. Okay, so let's...
10, or is it
No.
just 7 plus 3?
So it's just the 2 numbers that are here, the 7 and the 3. The 7 will go to the top and the 3 will go to the bottom. And you can choose to make this a base 10 or a base E. So for the next one, how about... Well, you wouldn't, that's what I'm saying. You always will. You always choose 10 or E because they're the ones that we can type in here.
Oh, Roger.
Okay.
10 or E, why not just choose 10 all the time?
You can, if you want to.
I could log base 6 for an example.
You could change it to a log base 6, but you won't be able to then calculate it because you can't type that in.
Yeah.
So we want to change it into one that we can use our calculator for. Just because we can. The second one, let's use log base E. Now, I actually prefer this one because you don't have to write as much. Log base E, the shortcut is just to write the ln. You don't have to write the word log, you don't have to write the base E. Okay, so I just go ln of 0.05 over ln of 2. And then type it in using the natural log button on your calculator. Give it a go, you should get minus 4.322. Okay? So that's pretty cool. We can change the base, which means we can type it in our calculator. Now for the second question, our second problem, solving exponential equations when we don't have bases that can be made the same. So we use our sliding base. I'm going to make that 3, the base 3, it is going to slide across to the other side. The x stays where it is. It becomes a log base 3 of the 5. Remember learning about that a few lessons ago? The sliding base. We turn it into a logarithm, and then we can use our change of base formula to find out what that equals. So let's use the log base E again. So ln of 5 over ln of 3. And it says 4 significant figures again. 1.465. Okay, question 2b, same thing. You can have a go. If you think this is pretty easy, give it a try. See if you get the same thing as me. First thing I'm going to do is my sliding base. The x is going to stay. It becomes log base 5 of 0.07. Then I use my change of base. So I'm going to use log base e again because it's the shorter one to write. ln of 0.07 over ln of 5. Shh, girls. That makes minus 1.652 to 4 significant figures. Okay? Everyone's good with that? All right. We're done with the chat, I thank you. You can wait outside if you prefer. Question 3 is a bit of an applications kind of question. So let's read through. It's just a bug, guys. Calm down. A rabbit population on an island is tripling every year. A few years ago, a study estimated that there were 600 rabbits there. How many years later will the rabbit population be 25,000? Answer in exact form and correct the nearest tenth of a year. Okay, so you can use whatever letters you want to use. You need to make an equation here. There's no set letter that you have to choose. But because it's a population of rabbits, I'm going to choose to use P for population. Okay, I'm just going to P for population. The population of rabbits, because it says that it is tripling every year, that's a key word. That is telling you the exponential part of this equation. No, it's not. Can you please stop interrupting? It is going to be 3 to the power of, I'm going to use the letter T for time, because it says time passes that the population is going to triple. Okay? Now, however, the population of the rabbits at the start is not going to be 1, right? So there is going to be some number that I need to multiply with that, which would be the initial population of the rabbits. So I'm going to call that P0, okay? Population at time 0 is the notation that I'm using there. You could use a completely separate letter if you wanted to. That is not the important part, as long as you understand that that pronumeral that I'm using in there represents the initial population of the rabbits. So in the question, it says, a study estimated that a few years ago there were 600 rabbits. That's my starting number, the 600 rabbits, and it's going to grow to the 25,000. So first of all, I'm going to sub in when P0 equals 600. And that's going to give me the equation P equals 600 times 3 to the power of T. Okay, now that equation could be used for any time. If I subbed in the time, it would give me the population of the rabbits. So I can also go in reverse. If I have the population of the rabbits as 25,000, I can go backwards and find out what the T is. Okay, so sub in when population equals 25,000, and I get 25,000 equals 600 times 3 to the power of T. Okay, get rid of the 600. So divide 600 across to the other side. You get 125 over 3. It doesn't go perfectly, but often questions don't go nicely. Now to solve that, I've got a power of T. Not a very nice thing to try and get a same base, so we're going to turn it into a logarithm. So the T is going to stay where it is. I'm going to slide the 3 sliding base. I'm going to slide the base across to the other side and turn it into log base 3 of 125 over 3. Now, we learnt some log laws yesterday. It does say in here, we want to find the exact form, and then we're going to do it in decimal places as well. So because it's said in their exact form, I can use some of those laws that I learnt to make that expression a little bit nicer. Because see the base of 3 and the 3 here? There's some simplifying that can happen in there. Because I'm dividing two numbers, I can change that to be 2 logs subtracted. It would be t equals log base 3 of 125 minus log base 3 of 3. Log base 3 of 3 is the 1. So I get t equals log base 3 of 125 minus 1. Okay, so that is exact, and that's probably the nicest version of the exact answer that I can get. But then it says to get the answer correct to the nearest tenth, which means I need to be able to type that in my calculator. So here comes the change of base so that I can type it in. I'm going to change the base to my natural log. So it would be log base E or ln of 125 over ln of 3. Okay, doing a change of base. Then you are able to type that into your calculator and we get an answer of 4.4 years. That's rounded to the nearest tenth, which is 1 decimal place. Tenth is 1 decimal place. Okay. Next question. There's a few different types in here that you need to be okay with, be familiar with. So next type over here, number 4. Use. Is it 3.4? I typed it in wrong, did I? Oh, I didn't minus the 1?
Yes.
Oh, well, lucky you guys are checking. Is it 3.4?
We do without Ben. Yes, 3.4. Honestly.
Not Ben Pass.
Ben Pass goes on my own side.
Is it? So I'm trusting here it is 3.4?
Yeah.
Okay, cool. All right, good. All right, question 4. Thank you, Rose. Use the substitution method that a is equal to 3 to the power of x to solve the equation 9x minus 14 times 3 to the power of x plus 45 equals 0. Okay. Are you missing a page? Get this on there. Okay. I need to write that whole equation with a base of 3 because that's what I want to sub into it. So the 9 that is there, I can change that to be 3 squared. Now the 2 would have to multiply by the x that was already there. So it's 3 to the 2x. Then I have minus 14 times 3 to the power of x plus 45 equals 0. Now that 3 to the 2x, I don't want to rewrite my whole equation, but that does mean 3 to the x squared, doesn't it? So I can switch the order of how I've written those two things there. I can put the x in the bracket with the 3 and put the 2 outside. Because what I'm going to do is I'm going to substitute, or I'm going to let the a equal 3 to the power of x. That's what it told me in the question. A is equal to 3 to the power of x. That means that this first one here is going to be a squared. A squared minus 14, and that 3 to the x is also going to be a, plus 45 equals 0. And it made a quadratic. We can solve that easy. So we're looking to factorize it. We're going to have 2 sets of brackets.
It's 9 and 5. Well, 9 and
minus 9 and minus 5, both of them negative. So we're looking for 2 numbers, times it to give the 45 and adding to give the minus 14, which is minus 9 and minus 5. Then both of those brackets are going to give me a solution. From the first bracket, a is equal to 9. From the second bracket, I'm going to get a is equal to 5. But the original equation, we're not trying to solve A, we're trying to solve for X. This substitution was just to help us. Now that I know what A is, let's go back. A was actually equal to 3 to the power of X. So I can say 3 to the power of X is equal to 9, and 3 to the power of X is equal to 5. And I can solve both of those. So for the left side, I can make the bases the same very easily there. No, I don't need to do that.
Oh,
9 is 3 squared.
Oh, it's so stupid.
It's all right.
Why did I say that?
Okay, for the other one though, I can't make a 5 a base of 3. So that one we do need to turn into a logarithm. The x will stay on the left, the sliding base, the 3 will slide across, log base 3 of 5. Now that is the solution. I'm going to choose to leave it exact. It didn't really specify. You could do a change of base there and work that out as a decimal as well though, depending what the question wanted you to do. Okay, question 5. We have an exponential equation that also has an inequality sign in it. So, this is what you need to know. Provided that the base of that exponential is greater than 1, you can treat that inequality sign just like a normal equal sign. And you can do sliding bases and all the other stuff to it. Okay, as long as that number is greater than 1. Okay, so just if that was a normal equals to sign, I would solve that equation by sliding the base. I would leave the x. Actually, no, I wouldn't. I don't even need to. 81. Can I make 81 a base of 3?
Yeah.
Yes. It's an easy one. I don't need to slide the base. So I can write 81 as 3 to the power of 4. If I can make the bases the same, that means I just have to compare the powers, which means that x is less than or equal to 4. You're treating that inequality just like you would a normal equal sign. Okay, it's just less than or equal to instead of equal to. B. Okay, we want to solve log base 10 of x is greater than 3. Treating it just like an equal sign. This time I am going to slide the base. I'm going to leave the x where it is. Greater than. The 10 slides across to the other side so that it's 10 to the power of 3. And 10 to the power of 3 is 1,000. So that solution is x is greater than 1,000. All right. Last question. These ones are going to take a bit of space, so write small. Solve the following equations by taking logarithms base 10 of both sides. So it's telling you from the start, to solve these equations, you have to take a log of both sides. It's kind of like if you wanted to multiply a whole equation through by 2, you can do that. You can also do it with logarithms. You can take a log of both sides, and that's just doing the same and keeping the equation balanced. Okay, so I'm going to take log base 10 of the 4 to the power of 2x, and I'm going to take log base 10 of the 5 times 4x to the power of x plus 3. Okay, the goal is we're trying to find out what x is equal to, right? So we have log laws, yesterday's log laws. On the left-hand side, I have this power here. So I can bring the power down to the front. Let's start with that. So it's going to be 2x log base 10 of 4. On the right-hand side, I do have a power, but we're not going to fall for the trap yet like we did yesterday. I have this 5 first. I have to do that multiplication because this one doesn't have the power. So I use the multiplication law to split that into 2 logs added. It would be log base 10 of 5 plus log base 10 of 4 to the power of x plus 3. Okay, now I can bring that power down the front for that last logarithm. Everything else I'm just going to leave on the same for that line, for the next line. And I'm going to bring down the x plus 3 to the front, and it'll be log base 10 of 4. Now, anytime you're trying to solve an equation for x, you only ever want, unless it's a quadratic, normal equations with x, you only ever want one x in there. So the goal is I need to try and get this x term and this x term together. So I'm going to have to expand this out so that I have the x away from the 3. So let's expand. We're going to get 2x log base 10 of 4 log base 10 of 5. And expanding, I get x log 10 of 4 plus 3 log 10 of 4. Okay, so now my 2x log 10 of 4 and my x log 10 of 4. We want to collect those up. Now they are actually like logs. That's a new term you haven't heard before. Like logs. They are both log 10 of 4, aren't they? So that means if they're like logs, we can do what we always do and we can collect up those like terms. So 2x, when I move that across, I'll be subtracting it. Subtract 1x would be 1x, or just x, log 10 of 4. And that then leaves my log 10 of 5 and my 3 log 10 of 4. Okay, I'm down to 1x, so that's a good sign. To get the x by itself, I will divide that logarithm underneath. So that is log 10 of 5 plus 3 log 10 of 4 over log 10 of 4. And because they are all log base 10s, you could work that out as a decimal as well. So you could type it all in. And I did it and got 4.16. That's rounded to 2 decimal places.
Would you be able to get rid of the one on the bottom and then make the second, like the 3 log 10 for just
That one and that one could cancel,
yeah,
but you can't take it out of that
yeah.
one. So you could split it into 2, like one fraction and one constant, yes. But yeah, it doesn't make it any simpler, really. Usually we prefer to have one fraction than to have 2 separate things. Okay, let's try it again. Another one very similar. We know we have to start by taking log base 10 of both sides. So it's log base 10 of 5 to the power of 3x equals log base 10 of 4 to the power of x plus 1. Okay, so remember any powers, we can bring them down to the front of the logarithm. So we're going to do that. The 3x comes down the front. 3x log base 10 of 5 equals, and the other one as well, bring the x plus 1 down the front, and it'll be log base 10 of 4. Okay, so remember last time, the goal is you want to get both of your x's together. So I'm going to expand that bracket. 3x log 10 of 5 equals x log 10 of 4 plus 1, or just log 10 of 4. Okay, so x term here, they are not like logs, which is a little bit sad, but we can move them to the same side.
But what is this? What's R?
That's a 5. It's my messy 5.
Why aren't they like logs?
Because they're both base 10, but this one's a 5 and that one's a 4. They have to be same base, same number for them to be like logs, okay? So I'm going to move the x log 10 of 4 across to the left. So 3x log 10 of 5, and I would subtract x log 10 of 4. And that equals log 10 of 4. So I've managed to get both my x's on the same side. So in this instance, to get just one x, I will have to factorize that x out of both of those terms. So x out the front, bracket, 3 log 10 of 5 minus log 10 of 4. It's not hard, it's just messy having to write these logs over and over again. And that equals log 10 of 4. And finally, to get the x by itself, I divide that whole bracket across underneath on the other side of the fraction. So log 10 of 4 goes on the top, and the whole bracket's going to go on the bottom. 3 log 10 of 5 minus log 10 of 4. And then you can do some calculator practice from there if you want to know as a decimal. So the number I had written down was 0.40 to 2 decimal places. Okay, but after you've done all that work, that's the easy part, hopefully. Type it in the calculator.
Oh, so you're talking about the question was easy.
No. Once you've got it to here, you've done all the hard work, hopefully typing it into your calculator is the easy part.